Hello everyone, welcome to G-Centric. So in this lecture, we will study about the duality concept. Okay, so this duality is not so important with GATE point of view, but in BARC or ISRO exam, they might ask questions based on this. So we have already seen this concept, but we do not know if we will call that concept as dual. Okay, so we have seen the source transformation, star delta conversion. Okay, and in theorems part, we have seen that Thevenin is equivalent to the Norton. Okay, and Norton can be made equivalent to the Thevenin. Okay, so we both are dual to each other. Also for these elements, so the dual of voltage is current, and for resistor it is conductance, inductor it is capacitor, open circuit, short circuit. Okay, then series we have got parallel, KVL is KCL, link is twig. So this part we will see in the graph theory. Okay. So they are dual of each other. For star we have delta, Thevenin we have already know that it's Norton. Then for switch open it's switch close. Okay. Then for nodal we have got mesh, and for power there is no dual because it is non-linear. Okay. So for the non-linear part the dual is not applicable. So all dual network are linear, but all linear network are not dual. Okay, so this is the statement, you have to keep it in mind. Okay, so by default all dual will be linear networks. So based on this we will see the question. Okay, you might be seeing the question number 243 where we have to draw the dual of that network. Okay, so there are some rules to draw that one. Okay, first we have to identify the loops in it. Okay, so we will name the loops. Okay, so this is loop 1, loop 2 and loop 3, and outside that we will take one more reference node. Okay, so that is called as reference node. We will put a dot over here, identify the currents I1, I2 and this is I3. Okay, I will draw over here. First is node 1, 2, 3. Okay, and this is the reference node. Now what we have to do is we have to move from 1 to reference node. Okay, so while moving you encounter with this voltage. So dual of voltage is nothing but current. Okay, so between 1 and 2. Now what should be the direction of the current arrow? It should be upward. Positive is upward. Okay, similarly see here the switch is closed. Okay, at t is equal to 0, the switch is closed, and from 1 to reference node we have got this switch, and voltage and switch are in series, so series will be equal to parallel. Okay, so that means we are making this switch open. Okay, so at t equal to 0. Next, in between 1 and 2 we have an inductor, so it will be converted to capacitor. Okay, so this is capacitor C. Next, here from 3 to reference node we have got a capacitor, so that will be converted to inductor. So 3 to reference node. Okay, inductor. Now in between these two again we have got R1 which will be converted to conductance, right? Okay, so now we have here resistor R1 which is basically from 1 to 3, right? So resistors will be converted to conductance. Okay, so this is R1. Okay, sorry, G1. Next again from 2 to 3 we have one more R2, right? 2 to 3. So that will be also converted to, okay, this is this way. That will be also converted to G2. Okay, so next what we are left with? We are left with this current source. So whenever you are solving the duality in the right side, what we have to keep in mind is that if this is plus minus, when it is going to be converted to voltage, we have to take the opposite polarity. Okay, opposite polarity, it means it will be minus and plus. Okay, so it is over here, minus and plus. Okay, it's only when we have the sources at the right side. Okay, so this is the question for solution for this question 243. Okay, next we'll come to this part, question number 244, where we have got this time the values as well. Okay, so what is the value now? We have 1 node and 2 node, and this is the third is reference node. Okay, I can draw over here Okay, so this is the reference node 3. Okay, and we have here 1 and this is 2. Okay, so now this is converted to, move from here 1 to 3. We have 8 volt voltage source, which will be converted to current source with 8 amperes. Okay, next from here to here 1 to 3 we have got resistor. It will be converted to conductance. Okay, but watch that this 8 volts and 3 ohms are in series, so it will be converted to parallel. Okay, so this is converted to parallel. It will be either 3 Siemens or 1/3 ohms. Okay, next we have in between 1 and 2 voltage, current source of 4 amperes. Okay, so why I have taken I1 a positive and I2 negative? It is because the current direction for I1 is similar to this current source. Okay, so that will be converted to voltage source. Since it is towards I1, this part is I1, so I will take it as 4 volts positive over this side. Next, in between 2 to 3 again we have resistor, which will be converted to 2 ohms is converted to 2 Siemens or 1/2 ohms. Okay, and again we have got voltage source. Now we have to take the opposite polarity, right? So if the current source direction, it will be like this when we do not take opposite sign, but it will be in downward direction when we consider it as the right hand side source. So this will be of 6 ampere current source. So basically duality means whether you interchange the sources or the resistor values or the voltage current source or inductor or the capacitor, basically it should not change its characteristics or its value. Okay, that's what we will call it as dual network. Okay, so this is about the dual network. Next we will see graph theory, locus diagram, okay, passive filters and 3-phase circuits. After that, this network theory will be completed. Thank you.